Hello guys, I am Parinita and welcome back to my channel to polish your CSE concepts with me. So let's get started. In this video we are going to learn about SLR1 parser. In my previous video we have already learned about LR0 parser in detail with the help of example, and now in this video we are going to proceed with SLR1 parser. Now if you have seen the video, if you have not seen the video, I would like to suggest you to see that video. I have explained each and every terms there in detail as it was the first example, but here we will be I am assuming that you have already seen that video, and so you must be already knowing the terms like what is canonical collection, what is action, what is go to. We have already discussed all the terms there in very detailed form, right? Now if I talk about SLR1 parser, in this case it is the example would be or the procedure would be very similar to LR0 parser. The only difference is filling the table. There would be some differences would be there. I will show you, but first of all, making the canonical collection of LR0 items, that will remain the same. So in this case also, first of all we have to make the canonical collection. So let's start it. As you know, what is the first step that we are doing? We are adding one augmented grammar. So first let's start with the augmented grammar. S dash gives dot s. Then I have to write, after dot we are having one variable. So I have to write the productions of this variable. So s gives dot a or dot small a. Now after dot one variable capital A is there. So I have to add the production of capital A also. Capital A gives dot small a. Fine. So this will be my first state of this canonical collection. Fine. Now after dot s is there, it is variable. So for that I have to make another state. So s dash gives, now s dot will come after s. So I will get s dot. Fine. This is my second state. Now for third state, here after dot I am having capital A. So I have to parse capital A. So parsing capital A, I will get a dot will come after a. So s gives a dot. Fine. Now s gives dot a, small a. So I have to parse small a. So parsing small a, I will get s gives a dot. Fine. Now if I talk about this, a gives dot a. So here also I have to parse small a only. So in this same edge in small a, I will write this also, that is a gives a dot. Fine. So the canonical collection of this grammar is very simple compared to the last example that we have seen. Fine. So here I am getting all the final items. Here also dot is at the end, here also dot is at the end, and here also dots are at the end. So I need not to move further. That means what? I have seen all the productions completely. So let me just name the states. This will be I0, I1, I2, I3. So all my productions have been visited in these 4 states only, I0 to I3. Fine. Now as you know, what my next task? My next task is to construct SLR1 parsing table. Now the main rule remains the same. We will be having action part and we will be having go to part. In action part we will be having the terminals. So which are the terminals are there in this case? The terminals are only small a, only one terminal is there, right? So in terminal I will be having small a, and apart from a I will be adding dollar, because in terminal where in action part always we will be adding all the terminals present in the grammar plus $1. Fine. So this will be my action part. Then what will come in my go to part? The variables. Which are the variables here? Capital S and capital A. Fine. Then what will come here? All my state numbers. So here my state numbers are 0, 2, 3. So 0, 2, 3 means 0, 1, 2, 3. These are my state numbers. So this is how I will construct my SLR1 parsing table. Now we will see how to fill this table. So how to fill this table? From in this zeroth row, for filling this zeroth row, I will see the I0 state. So from I0 state on capital S, I am going to I1. From I0 on capital S, I am going to I1. So I will write 1. From I0 on capital A, I am going to 2. From 0 on capital A, I am going to 2. Fine. Now, from I0 on small a, I am going to 3. From I0 on small a, I am going to 3. But as we know in the action part, whenever I am going from one state to another state with the help of any terminal, it is known as shift move. So here I will write shift move. So from 0, with the help of small a, I am going to 3. From 0, with the help of a, I am going to 3. So I will write shift 3, S3. Fine. Okay. So 0th row is completed. Now for first row, row number 1, I have to see I1. Now in this case, this is I1. In this case, this is what my augmented grammar. This is the acceptance state or the completion state of my augmented grammar that I have added. So in this case, as I have explained in the previous video also, this is known as one special case. So this is, in this case, what I will write in this is I1 state. So in the first row, under dollar, I will simply write except. Fine. Okay. Now moving further in I2. In I2 I am having one completion state. This is a reduce move because dot it is at the end, and S gives A. So my first task is to number all the productions. So let me number. S gives capital A as 1, S gives small a as 2, and A gives small a as 3. Let me number the grammars like that. So here I am having one reduce move. S gives A dot. Now what is the number of production of this S gives A? S gives A is my first number of production. So for this I have to write reduce 1. Right, I have to write reduce 1. But now the main question is where to write this reduce 1. In my LR0, we have seen the example of LR0. In that case, what we used to do, we were writing this reduce move in all the columns of action part. Remember, we were writing R1, R2, R3, whatever. We were writing this reduce move in case of LR0 in the whole column, in all the columns of this action part. But this is where SLR1 will be different. In SLR1, we will write this reduce moves only in the follow set of LHS. Where we will write it only in the follow set. We will write it in the follow set of LHS. This is how SLR1 will be different. We will write all the, in that case we used to write the reduce move in all the columns of action, but here we will write the reduce moves only in the follow of LHS. Now here too, S gives A dot. So this is a reduce move, reduce number 1. So I have to write R1, but where? Only in the follow set of S. Now here in this case, if I find out the follow of S, you must be remembering how to find out the follow, or I will suggest you to see my video of finding the first and follow and then come here again. How to find out follow set of S? S is my starting symbol. So always it will contain dollar, at least it will contain dollar, and after writing dollar we will check, is there any S in my RHS? No, there is no S at all. So no other thing will be there, only dollar will be there. So in this I2, in this second number row, I have to write R1 in dollar. I have to write R1 in dollar. Fine, simple. Then I3. In I3, S gives A dot. Again, this is reduced number. S gives small a dot 2. It is reduced number 2. And I have to write it in the follow of LHS, means follow of S. And we have seen that follow of S is dollar. So in the third, this is I3 state. So in the third row, I have to write R2 in dollar. Fine. Then we are having A gives A dot. A gives A dot. This will be my third production. Again, this is dot in the end. So this is R3 reduction. I have to write R3. But where I have to write R3? In the follow of LHS. Means I have to write R3 in the follow of A. Fine. Now what is follow of A here? We have to see that where A is present in the RHS. Here A is present in the RHS, but in this production S gives capital A. S gives capital A. In this, where is what is following A? Nothing is following A. Here we are having S gives capital A. So here nothing is following A. A is already the last symbol of this production. So if I am finding the follow of A, in this case follow of A, you have to remember those rules. Whenever this is the last element of the production, follow of A will be equal to follow of the LHS. Therefore, in this case follow of A will be equal to follow of S. So follow of A will be equal to follow of S, and we know that follow of S is dollar. So follow of A will also be dollar. Fine. So for A gives small a dot, I have to write R3 in the column of dollar. In third row I have to write R3 in the column of dollar. Here in the column of dollar already R2 is there. Along with it I have to write R3. Now the filling of my SLR1 parsing table is done. Now again the same rule, if there is any cell which contains more than one value or more than one entry, I can say that it is not SLR1. So as you can see, in this cell we are having more than one value. I am having R2 as well as I am having R3. So I can say that this given grammar is not SLR1. This grammar is not SLR1. So this is a simple rule that if any cell contains more than one value, but in this case we have to see some more specific. In case of all the LR parsers, we don't have to see if it is containing more than one value or not. Simply we will see about conflicts, that there are conflict or not. Now let me tell you little about conflict. We will be having mainly two types of conflict. See, whatever I am saying here, conflict and all, this will be true for all the parsers, all the LR parsers, right? So it was true for LR0, for SLR1, CLR1 as well as LALR1. Conflicts mainly we are having two types, that is SR conflict and RR conflict. What is SR conflict? Shift reduce conflict. SR conflict is nothing but shift reduce conflict, and RR means reduce conflict. See, the conflict we got here is what? We got two reductions at the same time. So this is known as what? Reduce conflict. That means two reduces will be there at the same cell. So we can say that there is a conflict and the rule will become false, that it is, in this case we have told that it is not SLR1. What is SR conflict? There will be one shift and one reduce at the same time. Reduce we got it, right? Like this. Two reductions will be there in the same cell. Now what is SR conflict? For example, if you are having something like A gives alpha dot, means whatever alpha is, you are having dot at the end. You are having one state in which you are getting dot at the end. A gives alpha dot. I am just giving an example. And for example, from the same state you are getting from any terminal, you are going to, for example, this is I2, for example, this is I3. There is any state I2 in which there is any state I2. In I2 we are having A gives alpha dot, means already you are having one production in which you are having dot at the end. Dot at the end means it is a reduce move. Fine, we know that whenever we are having dot at the end, it is known as reduce move. Fine, it is reduce move. Now, from the same state, on any small letter, on any terminal, you are going to another state. So, this is known as shift move, because we are entering in the table as S1, S2, S3 like this. So, whenever from any state you are having you are getting the final production, that means it is reduced, and on any terminal you are going to some other state, that is shift. So in this state you will get what? Shift reduce conflict. So whenever you are getting shift reduce conflict or whenever you are getting reduce conflict, in case of these two conflicts in any cell, you can simply say that grammar is not valid. Fine. So we have to take care about these two conflicts for all the LR parsers. So here also we have got reduce conflict. So we can say that this is not SLR1. Fine. And all the blank spaces, what this, see, in this table we are having these blank spaces. What these blank spaces say? these blank spaces means these are number of errors. You can say that these are number of errors. And why I am telling you that? Because in many exams, what they are doing in MCQs or something like that, what they are asking, they are giving this and they are asking how many number of errors are there. Or for example, they will say that this is a grammar, it will give more error in case of LR0 or SLR1. You have to say the correct answer. So what we have to do, you have to construct the LR0 table also, you have to construct the SLR1 table also, and you have to count the number of blank spaces. Wherever number of blank spaces are more, that means number of errors detected are more. So in this way you have to take it that whenever we are having blank spaces, they indicate error. Fine. So these are some of the points that you have to remember. This about blank spaces, about the conflicts, two types of conflicts, SR and RR. RR we have already got here, you have seen the example. SR I have shown you the example, that if any state is there in which you are having reduce move, and from any terminal you are going to another state. This is shift plus reduce, so shift reduce. So in these cases you have to take care. If we are having these conflicts, then we can say that our condition holds false. So that's all. So what we have seen, that in what was the main difference between LR0 and SLR1, that in LR0 we were writing the reduce moves in all the columns of action, but in SLR1 we will write the reduce moves only in the follow of LHS. Fine, this is the main difference between these two. Only writing the reduction moves is the difference between these two. I hope you have understood it clearly. You are very clear with LR0 and SLR1 both. Now in the next video, just for your practice, I will take couple of more examples, and for the same grammar we will determine whether they are LR0 or not, SLR1 or not, and LL1 or not. We will see all the three conditions, all the three parsing table in the same grammar, so that you will get a clear idea. Fine. So guys, that's all about SLR1 table or SLR1 parsing. If you think that my video was helpful, please subscribe the channel and let me know that you liked it by leaving the like and comment in this video. Thank you so much.